We say please and that's just going to be, ooh, you know what, that's, yeah, it's tricky, isn't it? That's a new, that is a new item to keep track of where we are in the, no, shit, I gotta think this through. Give me 1 second. Yeah, I've thought about it and it looks like we will need one more member variable. The thing is, what we're keeping track of is just these samples, you know, where we are in, not in the window, in the global thingamabob, in the global red object. That's the index we're keeping track of, and also we're keeping track of which blue index. But we weren't keeping track of the green things, and the green windows are the actual windows. So window A sample, yeah. That's not the best name for it then. Window A index. No, that's fine. We can just do table index. M table A index. Like that. You know? And we can initialize those to both 0 as well. M table A index equals 0. By the way, typing Shift A, Shift I is one of the hardest things for me to do. Somehow I got in the hand of making sure the opposite hand uses the Shift button, but in this one case where it doesn't work out nicely. I used to use the same hand for Shift A. Maybe I still do, I don't know. But that time it felt really weird. Okay, so now we have this sample being tracked as well. Note that we aren't incrementing them or anything yet, but that's fine. For now we assume they are properly being handled. We just use them. Yeah, so that was like this. Yep. And here we just say M table A index, like that. And we just do that twice. And this gets called a lot and repeatedly. So we want to have a table for this, a real table eventually. When we're talking about actual sinusoids and all that for our Hamming windows and Hanning windows, at that point we don't want to waste time computing that. We want a table. Yeah, I need a drink of water because my throat's getting tired. Oh, that's good. All right. So this handles the A. Where is that? The A window. Now the B window should... The A window will always be writing. That's the nice thing about the A window. The B window, it could always be writing. I mean, what we could do is we could start the first... Yeah, this is what we can do. We start the first B window out like this and just start in the middle. That's... No, that's not nice though, because that will create a click. And that's true for the A window too as well. Yeah, at the end, I mean, tricky stuff, huh? Yeah, I can't really say which would be better. What I'm gonna say though is the speed at which these windows move is also different, so we can't do a tricky thing that uses that to determine whether we should, when we should have B come in. Yeah, so for now I'm going to do it like this. I'm just going to draw the B window and start here. We'll deal a bit with silencing that initial window later. And that way we don't have to do anything special. Yeah, and these are not in if statements anymore. Later on they will be when we start omitting that initial B window and last A window. A window. B window. Right. So yeah, this is the same except all the A's are B's. So that's not so hard. One thing that is different though is that this is now a plus equals, and not only that, we now need to initialize that B window to be something reasonable. So that initial B sample is 0. Is that true? No, that's not true. That initial B sample yeah, right. I think that initial B sample can be K stretch window size divided by 2. And the reason for that is, I mean, this will be -1. And that's how we can do it. This is not good because it assumes the stretch, the B sample. Ooh, this is hard to explain. This needs to take into account the speed at which A and B are moving. If they're moving at the normal rate, this is fine, but we probably want a sound that stretches, so it won't be. So there's one important variable that is not in any of this yet, and that is the stretch speed. So we'll just have float stretch speed, and we'll have to make a comment about what this is. Stretch speed is rate stretch rate, maybe? Stretch rate, yeah. Stretch rate is the number of times slower that the sound should go. E.g. 2.0 is twice as long an output sound. Now, if you vary this kind of thing, you can have stretch rates that are less than 1. That's a possibility. Or if you simply cache the output, cache the input until you have a certain, until you have enough, you can have a stretch rate less than 0. Those are the only two cases. That was an aside. So we'll set mstretch rate to be 1.5 for now. How about 2.0? That's a nice round number. Yeah, it's 402. Alright, I gotta change my posture. I was sitting on the chair backwards. Oh, that makes... It uses a different bunch of muscles. Alright. Now that we're in serious mode, we've got this B thing. It pretty much works. It'll pretty much work. We have to tweak these initial parameters though. So that stretch rate is really a speed, so when we have a higher amount of stretch, I'm not sure. I'm really not sure yet, but this is what we can do. We just make sure that that these are positive. Take that back. Yeah, one of the nice things about this system is we just make sure... shit, I forgot. The window sizes are not related to the buffer sizes. Yeah, that is tricky. That is tricky. So I can't do this. But we can use this in table B index. Yeah, I like that. So this will be a special flag when this guy's negative. So when it's greater than or equal to 0, you do that stuff. That's good. I like that. And this is where we increment window